Hello Internet, hello friends. Welcome to a new video about 3D printing. This video is for the beginners who just bought a printer and now make their first steps into 3D printing. In this video, we are focusing on FDM printing, fused deposition modeling. I try to remove the stumbling blocks and obstacles to help you get started. We highlight the setup of a printer, the startup. We will also have a look on some of the tools and the overall workflow. Imagine making cool toys, tools or decorations right in your home. That's what 3D printing does. Let's go on a journey together from opening our new printer to making our first little project. The 3D printing universe can be a bit intimidating at first. I will explain the most important keywords and the general workflow for FDM, Fused Deposition Modeling 3D printing. This is the process where we melt plastic and build an object layer by layer using a computer-controlled 3D printer. Let's break down the process of FDM, Fused Deposition Modeling 3D printing, into simple components and steps. Let's start with the filament. This is the material used for 3D printing. Common types include, for example, PLA, ABS and PETG plastic. PLA is a biodegradable plastic derived from renewable resources. PLA is user-friendly and ideal for beginners due to its low warp properties and easy printing. There are various other types of filament you can choose from. Let's pick ABS and PETG out of them. ABS, it's known for its durability and heat resistance. ABS is a petroleum-based plastic widely used in automotive and consumer products. And last but not least, PETG. It combines the ease of printing from PLA. PETG has nearly the strength of ABS, but other different advantages like the chemical resistance and transparency. 3D printing filament comes in different lengths, sold by weight, and it comes in different diameter sizes. I highly recommend starting with smaller rolls of filament, for example 500 grams, as the filament can absorb moisture from the surrounding air over time, which changes some of the physical properties and makes the filament harder to print. You can choose from different filament sizes. The diameter of a 3D printing filament largely dictates its compatibility with different printers. The most common size is 1.75 millimeters. This is a thinner filament, it's widely used and compatible with the majority of the consumer 3D printers. It tends to heat up and melt faster due to its smaller cross-sectional area. Other diameter sizes are 2.85 millimeters or 3 millimeters. This is a thicker filament, is less common, but preferred in some specific printer models. The diameter is determined by your printer's hardware. Read the reviews for the filament. There are big differences in the quality between different brands. Make sure you set your printer to the correct nozzle temperature, the correct bed temperature, and all other recommended settings by the filament manufacturer. You may find pre-settings in the slicer program for the larger brands, but double check the settings to make sure they are right. Let's continue with the next component, the extruder. The extruder is responsible for feeding the filament to the hot end. It grabs the filament and pushes it forward. In FDM 3D printing, there are two types of extruders. Bowden extruders and direct drive extruders. A Bowden extruder has a long tube for filament to guide the filament to the hot end, which can make printing flexible materials difficult because of the friction of the flexible material in the tube. But the print head is very lightweight and therefore it moves very fast. Let's have a look onto the direct drive extruder. Here the extruder is closer to the hot end and therefore the control over the filament feed is better and no tubing is required. This makes it great for flexible materials and an overall clean print. But there are also disadvantages of a direct drive system. It's the increased weight of the extruder and the hot end as one component. The combined weight can slow down printing speeds, especially in printers that move the extruder and hot end assembly a lot. And another important point you should mention before you buy a direct drive system is the complex maintenance. With the components closely integrated, addressing issues or changing parts can be very complicated. Keep that in mind before you buy a 3D printer with a direct drive system. Remember that both devices need to be cleaned regularly to work well. Keep them free of debris and your 3D prints will be just right. Now we come to the hot end. As the filament reaches the hot end, it gets melted. The hot end is like the tip of a glue gun, turning the solid filament into a molten state so it can be laid down layer by layer. In your FDM 3D printer, the hot end plays a very important role in turning your filament into your 3D creations. Let's break it down. The hot end consists of a few key parts. First, there's the nozzle. This is where the melted filament comes out. It determines the size of each layer in your print. Then we have the heat. The heat block houses the heat cartridge and thermistor, helping to control and maintain the hot end's temperature. Then we have the heater cartridge. It heats up the hot end and melts the filament. We already mentioned the thermistor. This is the sensor that measures the temperature of the hot end, ensuring it stays at the right level. Last but not least, we have the heatsink. The heatsink helps cool down the filament right above the heater block, preventing it from melting too soon. You can choose from different nozzle sizes. The nozzle size is like the brush tip for your printer. It determines the width of each layer in your creation. The standard nozzle is 0.4 mm. It's perfect for a wide range of printing tasks, but there are also smaller nozzles like 0.1 or 0.2 mm. They are ideal for intricate and detailed work, but might cause longer printing times. And there are also larger nozzle sizes like 0.6 mm or 0.8 mm. They are allowing for faster printing but with less fine detail. Changing the nozzle size might also require you to change your printer settings, for example, the extrusion amount, print speed, and other settings. In the end, it's all about finding that perfect balance between speed and precision for your creation. And there are some important notes I should mention here. Keep the nozzle clean to ensure a smooth flow of the filament. Maintain a proper temperature setting for the type of filament you're using, as already mentioned. Regularly check and clean the heatsink to prevent clogs. Make sure you read the recommendations for your printer. Always handle the hot end with care and avoid touching it during or immediately after printing, as it gets extremely hot. And I can tell you, I proved it. I think with these insights you're on a good way to mastering the hot end and creating amazing 3D prints with your FDM printer. There are another two important components in 3D printing, the print bed and the base plate. The print bed is the surface on which the object will be printed. The base plate provides support to this bed. The print bed is not just any surface, it can be heated, and this feature is critical when working with materials like PETG or ABS. These materials require high temperatures to adhere well and have minimal warpage. The heated print bed provides the necessary heat for successful prints with these materials. But also for PLA it helps a lot to prevent warping. Meanwhile, the base plate, which is usually made of materials like aluminium, provides stability and support for your 3D printer. Nowadays, most of the print beds are heated to ensure the first layers of the print adhere well and stick to the print bed. There are various types of print beds. There are flexible beds that bend and flex, making it easy to remove without damage. There are also glass beds where prints stick firmly, providing excellent adhesion, or other special materials and types like build-tech or magnetic print beds. So whether you prefer flexibility, the clarity of glass, or the magic of special materials, your choice can make all the difference in the quality and success of your print. Another important topic is bed leveling. This is a critical process in 3D printing. It involves adjusting the position of the print bed to ensure that it's level and parallel to the printer's X and Y axis. The primary goal of the bed leveling is to achieve uniform and consistent first layer adhesion. When the bed is level, the nozzle can move across the bed at a consistent distance from the surface, allowing the first layer of the 3D print to adhere evenly and securely. This is essential for producing accurate and high-quality 3D prints. The next components are the stepper motors. These motors precisely move the various parts of the printer in specific directions, like the extruder or the print bed, which again depends on the construction of the 3D printer.
Proper calibration of stepper motors is crucial for accurate 3D printing. This includes steps per millimeter calibration to ensure that the printer moves the correct distance for each command. More about calibration later in this video. In the world of 3D printing, precision is paramount, and that's where linear guides, rails and rods come into play. Linear guides ensure smooth and precise movements along a specific path or axis. Think of rails as the sturdy foundation. They provide a stable track for linear guides to glide upon. Ensuring that your rails are clean, straight and properly aligned, this is essential for flawless 3D prints. Rods are the backbone of your printer structure. They keep everything aligned and in position. Like any machinery, your 3D printer requires care and attention. I highly recommend Teflon spray, PTFE spray for lubrication. Teflon spray provides an excellent lubrication without attracting dust. Regular cleaning, lubrication and checking for any signs of wear on linear guides, rails and rods are essential to keep your prints accurate and your printer running smoothly. And this is essential for precision in 3D printing. And that's where belts and linear movement come into play. Belts are very important for moving the parts of the 3D printer. They are responsible for guiding the print head or the build platform with pinpoint accuracy. Belts ensure smooth and synchronized movement layer by layer. Therefore, correct belt tension is vital. Belts that are too loose can result in backslash and imprecise movements, while belts that are too tight
can strain the printer's components and cause excessive wear. Follow the manufacturer's guidelines to achieve the optimal tension. The brain of the 3D printer is the mainboard. The mainboard receives or reads instructions from a digital 3D model, usually in the form of a G-code file. More on that later. With this G-code, it controls all the parts of the printer and executes the G-code instructions. Your 3D printer's control panel is your command center. Let's explore its most important functions. Number 1. Navigation. The control panel allows you to navigate through menus, select options and adjust your print settings. Number 2. Temperature control. The control panel allows you precise control of the print bed and hot end temperatures. Adjusting these temperatures ensures perfect conditions for different materials, like I already mentioned in the filament section. Number 3. Print start and stop. Press a button and your printer comes to life. When the print job is finished or a pause is needed, you can stop it with another button. Press and giving you control over every aspect of your print. Number 4. Filament loading and unloading. Filament handling, load, unload and change filament is possible. With just a few clicks you can load and unload filament with ease, so you can change the filament material or color for creative projects. Number 5. Progress monitoring. Keep an eye on the progress of your print. The control panel provides real-time updates so you can take action when needed. Number 6. Calibration. This is very important, as I already mentioned. Fine-tune printer settings include leveling the print bed or adjusting the nozzle height. Calibration ensures accurate prints every time. And number 7. SD card and USB input. The control panel helps you to load your 3D models from external storage, like an SD card or a USB drive. Make sure you get familiar with the functions and the navigation in your control panel. This is an essential prerequisite to achieving good results. Here is a more detailed overview of the 3D printing workflow. Let's have a closer look at the individual steps. In a typical 3D printing workflow, we'll take an already prepared 3D model in the form of an STL file, or we create a 3D model using 3D modeling software, and then we store the model as a STL file and load this STL file into a slicer software, like the Cura or the Prusa slicer software. In the slicer software, we slice our model into individual layers and create the related machine instructions for our 3D printer. These instructions are stored as a G-code file, and then we transfer this G-code file, for example via USB, from our computer to our 3D printer for printing. Thank you for joining us today as we delved into the fascinating world of FDM 3D printers and their construction types. Make sure to tune in for part 2, where we will dive deep into the crucial steps of 3D printing calibration and the art of slicing. You won't want to miss it. Until then, keep printing and exploring the limitless potentials of 3D technology. Stay creative. See you soon. Bye, Freetown.